2, chapter 3, chapter 2. We're starting in book 2, chapter 3, chapter 2 of the scopes and closures. I have Stephen and Josiah with me. Josiah, Josiah, you wanna introduce yourself?
Okay. Hello. My name is Josiah Rodriguez from Dominican Republic. I'm working from Free Code Camp curriculum. I'm right now in basic JavaScript and working through reading the books you don't know JavaScript. I'm right now in book 2, chapter 3, and I read and trying to understand what I read. I'm here to learn more, and
Yeah, glad you could join us. Thank you. We also have Stephen, who's on chat. He can't talk right now. He doesn't have a mic. He said he'll get one hopefully by next week. But he's been coding since November. He started, and he's working as much as he can. I think about 4 hours a day he's coding through. So we're glad to have him on board, and hopefully we can get this thing going here and learn some stuff about JavaScript and closures. So all of us are on book 3 or book 2, chapter 2 or 3. I wanted to just get y'all. Do y'all understand lexical scope and understand what's going on with lexical scope? Oh, hold on. Steven actually just posted some more stuff. So I'm going to read this out to you. He just posted on here. I'm Steven. I live in Massachusetts. I started FCC in November, but found P1XT's guide and started following those. I'm trying to keep up with typing. Oh, I just kept reading. Sorry. But I'm glad you can make it, Stephen. Let's see here. So do y'all understand lexical scoping? Are there any questions on that? I know that this diagram, I think I can share my screen. Here we go. I think this diagram did a really good job of kind of breaking down lexical scoping for me. It really helped me out understanding it. Do y'all kind of get what's going on with this? How you have your scopes of functions and your curly brackets, and each layer has its own scope. When I first started learning how to code, this was really difficult for me. Yeah, the diagram was very helpful. But I actually knew a little bit about lexical scoping because I watched a video through Udemy called YDKJS, or Understanding JavaScript, the Weird Parts. I'm sorry. And they went over this, and that kind of just, I had my aha moment when I watched that series. But this really gave me a visual on it. And when I first started learning how to code a year ago, function scopes and if scopes and all that stuff was really confusing for me. So I'm glad that they really go into detail in this book series. What else here? I don't really want to go over the eval stuff or the WIS stuff. It's just a nice to know, but I found that it was confusing me a little bit. I get it now on my second read through. I tend to read these chapters through twice or 3 times if I really don't understand it. But I've never used with, and I don't think I ever will. It seems like a use case scenario. But eval I did use mistakenly my first time through Free Code Camp. I used it for the JavaScript calculator to evaluate the inputs for the calc. So I did use this, and I didn't understand why people were saying not to use it, but it's just injecting code after runtime. That's pretty much it. So it doesn't go with it doesn't follow the author generated code. It injects it in after runtime, so it could screw up your global scope. Yeah, they don't really get used. I think Stephen asked a question here. Here we go. So that felt pretty good about the diagram. Those are those two things aren't really used anymore. Yeah, they're not. At least with width, they're not. And eval is bad practice, so yeah, they don't get used that much. Every form that I've seen eval on, they say don't use it. It's bad practice, and it actually has some security issues with it since it's injecting. Correct me if I'm wrong, anybody that's watching this. I think it has some security issues with injecting pure JavaScript from an eval function into your code. So you can, let's say I had an input field that's using an eval on it, with that data, they could literally write code that gets injected into your own code and cause some damage and change some stuff. So there's security issues with it, I think. Performance is another one. I forgot about that. I really like this book series review sections. I find them very helpful. I don't know if I just tend to browse back through some of the chapters that I've read, and I just read the review section. It's like, what was lexical scope again? And I just go through the review and I'm like, oh yeah, that makes sense. I don't want to read everything again, but it just does a really good, quick review of everything, which is why it's titled that. But I find that these are very helpful instead of just having detail of information that you have to scroll through to find your answer when all you have to do is scroll down and read the review. So I'd utilize this if you don't already. Let's go over to a fun one. Function scope versus block scope. Hold on, I think you're asking a question here. What I started doing was reading the TL. Yeah, that's a good idea. You started reading the review section before doing anything. That's a good idea. I haven't done that, so I might actually try that before, just so I have an idea and I can kind of place it, like you said, while I read. That's actually a really good idea. So function scope versus block scope. Do y'all have any questions on this? I found this one to be probably the easiest in this section in the scopes and closures book. Do y'all find this hard, or do y'all find this confusing in any way? We can go down and read the review section just so everybody kind of, yeah, it's pretty straightforward. It is very long, but I found that it was very well explained in this, and I was able to follow along quite well with this one. Functions are the most common unit of scope in JavaScript. Variables and functions that are declared inside another function are essentially hidden from any of the enclosing scopes, which is an intentional design principle of good software. Yeah. Oh, here's something I forgot. The let keyword, ES6 stuff. Yeah, this one was pretty good. I like this chapter. It was easy to follow. The next chapter, though, was the one where, Jose, have you read this one yet? I know you said that you were on this. I think you were on this chapter, right? And Steven, did you finish this one?
I read it, yeah. I read it already.
You read this one?
Yes.
Did you have any questions on this one?
I don't. No, not really.
Okay, cool. I'm reading a question by Steven here. That's a good question. So Steven actually had a good question. He says he only uses JavaScript in a practical sense, such as writing small algorithms. And he doesn't really understand why you use blocks to hide code. So his question essentially is, when would you use blocks to hide code? You use blocks to hide code when you need, how's a good way to explain this? And this is exactly why we do this, is I understand it in my head, but now I have to word vomit it out in a way that you can understand. So give me a second while I put this together in my head. One big reason is, are you familiar with jQuery, Steven?
No.
Okay, so so jQuery is essentially a framework, right? It's JavaScript. So let's say I'm writing my own JavaScript, and I want to utilize someone else's JavaScript that they already wrote. And that's what jQuery is. We're essentially utilizing someone else's JavaScript that they wrote. And it makes it easier for us to write JavaScript. That's essentially what jQuery does. It makes a lot of the functionalities of plain JavaScript easier. So all they did was they wrote this framework or library in plain JavaScript and essentially made jQuery. Well, that means that there's a lot of variables and a lot of stuff that they need to keep separate from your code. So if they wrote it all in one big global one big global scope, then when you import it into yours and you want to utilize it, you could be overriding some of their code. So it's good to scope out or block out different sets of code so you can utilize someone else's code without it conflicting with your code. So if they had something that you named something and you overwrote it, well, then you just broke their code. So blocking it out and making it to where they have their own scope, it essentially keeps it safe from what you're doing. That's the biggest example I can give. And there's a lot more there's a lot more small examples, but I think that one you would be utilizing once you get into the jQuery sections. That's kind of what jQuery is doing. It's its own scoped framework, and it's written in plain JavaScript, and you can't mess it up unless you really try to mess it up. Yeah, it is. I didn't think about it either. I really learned that from that understanding JavaScript, the weird parts. They went into detail about, and they use that example. Like I said, there's a lot of other examples on why you want to scope stuff out. So if you need to utilize a variable inside of a scope, but you also need to create a new variable, but you don't want it accessible from anywhere else in the program, then you would scope it out into a nested scope. So it's hard to give really good examples when I'm not prepared, sorry. But jQuery is probably the easiest way to think about it. When someone else writes code, they want to scope it out to where you can't have access to all their variables and overwrite them. And vice versa, they don't want to screw up your code either. Cool, glad you understand it. Does that make sense, Jose, though?
Yes, yes.
Okay, good.
You say when you want to hide your code for other people not to use it. Or
that's one example.
yes.
Yeah. So we'll go to the fun part. The fun part in this chapter for me was the, oh, no, it's wasting first. This one was actually new to me. I knew that JavaScript hoisted, but I didn't know how JavaScript hoisted. So I don't think, have y'all both read this? Chapter 4, hoisting?
I read a little some days ago.
You did an overview? Okay, so let's go down and take Steven's advice and read the TLDR. We can be tempted to look at var a equals 2 as one statement, but the JavaScript engine does not see it that way. It sees var a and a equals 2 as two separate statements. The first one, a compiler phase task, and the second one, a execution phase task. What this leads to is that all declarations in a scope, regardless of where they appear, are processed first before the code itself is executed. You can visualize this as declarations, variables, and functions being moved to the top of their respective scopes, which we call hoisting. Declarations themselves are hoisted, but assignments, even assignments of function expressions, are not hoisted. Be careful about duplicate declarations, especially mixed between normal var declarations and function declarations. Perl awaits you if you do. So what this is saying is that when you start creating vars and functions, what JavaScript does is it goes through your code and it takes those functions and vars and moves them to the top. And then it will essentially assign, it will allocate memory for those functions and vars, but it won't give them assignments. So what I mean by that is if we go up here and we take a look at var a here. So if I had var a equals 2, let's go find that. So when the code runs, and it would run through this, right? And we're not looking at function right now. We're just going to look at var a. So when your code looks through, when JavaScript looks through your code and finds var a, what it does is it takes var a and moves it to the top of your code. And then it allocates memory for a. And that's why you get undefined whenever you try to access a variable and it hasn't initiated yet or executed yet, because it hasn't gotten to this execution portion of it, which is the equals 2. So after it allocates memory and it hoists it to the top, var a equals undefined, it would then run through your code in order and start doing the executions. At least that's what I took away from this. Yeah, I think that's what it said. I know that there's a difference in the way you initiate a function. So like this would be the way I just explained it, whereas this would not. This is a little bit different. So both function declarations and variable declarations are hoisted, but a subtle detail that could show up in code with multiple duplicate declarations is that functions are hoisted first and then variables. So technically functions will be hoisted first and then variables. But I know that if you set a var foo equals function, that is treated like a normal variable. So the function won't get executed. I'm trying to find where I said that. Yeah, here it is. So functions are hoisted first. This would be hoisted first to the top and set memory somewhere before it executes. And then variables. Well, if you have something like this where a variable equals a function, then this, with this equal or assignment operator, this is just treated like a normal variable, even though it's technically associated with a function. Does that make sense to you guys?
Yes.
Cool. So that one wasn't too bad for hoisting. The fun part is scopes and closures, or scopes. Scope closures is what I meant to say. This is where the confusion came quite a bit when I read this the first time. I had to really walk through how closures worked with a couple different people, and they had to explain it to me before I really understood it. And I don't think, are y'all both on this? Okay, closures, yeah, closures are confusing, I agree. I'm trying to think of a good way to explain this. Okay, let's take a look at this first one. Let's do what Stephen said again. Let's go down and read the TLDR. Closures seem to be the unenlightened like a mystical world set apart inside of JavaScript, which only the few bravest souls can reach. But it's actually just a standard and almost obvious fact of how we write code in a lexically scoped environment, where functions are values and can be passed around at will. Closure is when a function can remember and access its lexical scope when it's invoked outside its lexical scope. This is probably the biggest, and that's why it's bolded. This is probably the biggest hint of what closures do. So try to understand that sentence. Closure is when a function can remember and access its lexical scope even when it's invoked outside its lexical scope. So let's say inside a function, I have another function. If I set that function, well, let's go back up and read this because this is essentially that. So we have a function inside of a function, right? So I'm gonna make sure that this is actual closure because I think it is. No, this is closure. This one's a closure. So what this is doing, we declare our function. We have var a equals 2. And then we have inside the top level function foo, we have function var. And that console logs a. So what we do when foo runs, we return bar, which essentially just returns this function. So we're going to run foo, and we're going to return the function var, because it's essentially, or bar. So when we return bar after we call this function, whatever the variable is when we assign will be bar. So right here we have var baz, right? This is just a variable, and then we're assigning it to the return value of foo. So when foo gets called, right here, we return bar. So this is a return value, which is now bar. So that bar goes into baz. And when we call baz, then we get the console log a. Should I try to explain it again, or does that make a little bit more sense on what's going on? So when we call baz, we're getting the value of we're getting value from bar, even though bar has already run. Bar hasn't actually run yet. So, or at least not that I'm aware of. This could be something that I'm missing. But in my understanding, you're essentially just going to set okay. So when foo runs, it returns bar, which is just another function. So let me do this. This is React, I'm sorry. I started my JavaScript thing today. So where can I write this and it actually make it through? Ooh, I might actually have something over here. we'll go back. We'll just do it here. Okay. Make sure this works real fast before I continue. Yeah, okay. So we have two. This is our console log from bar. So we essentially got this, right? So if I take out all the stuff of foo, I just keep var. If I just keep var, I run bar, we should get console log 2 again. Okay. So if we set this to a variable, our test equals function bar, and we run test2, we should still get bar, right? Or console log 2, right? Yeah. This is essentially all we did inside. We essentially just said, hey, in this function here, if I can find out where it was. Let me read you, Stephen. Hold on 1 second. Yeah. What we did here is we gave Baz access to bar from this return bar. So we told function foo to return another function. So then we set Baz to that return function. And now we can call Baz as function bar. So Baz is essentially, Baz is just this. These names don't matter. Baz essentially is just replacing bar because of this assignment operator right here. Because of what foo does. Foo gave us bar back after it ran. So when foo returned bar, it gave us the function bar to set equal to Baz. Now Baz is a function, which is essentially just the bar function. Yep, exactly. That's closure. I mean, that's a basic level of closure. If you can understand this and really wrap your head around just this little snippet of code, it really opens up your eye to it. All you're doing is calling a function that returns a function, and then when that function finishes executing, we can set it equal to a variable, which allows us access to internal functions of a different scope. Yeah, that is a trick, just wrapping your head around that. This was definitely one of the more confusing topics. This keyword, and then also closures. But a lot of stuff uses closures. You just don't realize it. I don't use them that much, and I want to put this in practice more often. I don't do it enough as I should. And we can go down and work through some of the other problems in this because there's a couple really good ones in here. Let's go down here. This was another good one. So let's see if I can explain this one. Hold on, I see something here. Yeah, so this doesn't make This does make more sense though. That's the problem. I have never actually coded anything of substance in JavaScript, so I have no code of my own, just those FCC algorithms and stuff. Yeah. And that's just going to take projects. The only way you're going to get better at it is to actually do it all the time. Like I spent the first like 4 months of learning to code just reading stuff, and that actually did nothing for me. But after I got into the free code camp stuff, which was back in April, and I actually started writing JavaScript every day, it really helped me feel comfortable with making JavaScript work how I want it to work, instead of me trying to figure out how to make JavaScript work. I could make JavaScript work how I want it to make it work. I'm still not good at it, of course, but looking back on my code a year ago and looking at my code now, there is a big difference, and it's a lot of fun when you're actually able to see the progress that you made. It's very, very encouraging, like you said. Yeah, it's very, very encouraging when you can go back and look at what you wrote and then come back 4 or 5, 6 months later and go, damn, I'm an idiot. What was I doing there? It's a lot of fun. That's why I'm still doing it. This one was complicated when I looked at it the first time, and this is the one that actually got, this is the one that actually went through with the guys last time I did this. This is the one that I really kind of grasped and was able to explain, or maybe not able to explain well, but once I wrap my head around this section of code, because it is a little bit more confusing, this helped me. So I need to remember now, hold on. So foo is calling a baz function, which is just a, and then we call bar, which we run function. So we call foo baz. Okay. So what we're doing here, guys, is that we are declaring a global variable fn. So this has access anywhere, and I think this is the real takeaway in this one. We're setting a variable inside our global inside our global scope. And we have another function foo, and if you notice down here, we run foo before we run bar. This is very important. So we run foo first. And what foo does is it does just like our last one, except we don't have a bar. We have an extra little step here with baz setting to fn. We don't return anything. We set something equal to something. So we run foo first. We have var a, and then we have function baz console log. This is essentially what we did last time. But right here we have fn equals baz. So we set fn, which is our global variable, fn, to a function call, which is baz. So when this function foo gets completed, we have access to the baz function on fn. So when that happens, we run bar. What bar does is all it does is run a function, fn. And what was fn equal to? Fn was equal to baz. So fn runs, and we get 2. Yep, that's pretty much it. And then we run bar. What he said was foo goes first and assigns the baz function fn. And then we call bar, which is just the baz function, and it console logs 2. That's it. I mean, that's literally closure. And we'll run it over here so we can see it. We got 2 again. Yep, that's all that's going on. So we have a global function or a global variable fn. We run foo, a function baz to the global variable fn, which is now the baz function. which console logs A. So then fn is just a console log function of baz. Then we run bar, which bar is running a function fn, which we now know is just baz console logging A. That's it. That's Clojure. This is jQuery, by the way, and y'all haven't used it, so we won't go over it right now. Oh, this was a fun one. The self-initializing functions. Those were fun. I didn't know these existed before reading this book series. This one looks like it runs a function or runs some. Here's another one. This is the one I was looking for in modules. These were confusing for me too. There are other code patterns with level the power of closures, but which do not on the surface appear to be about callbacks. Let's examine the most powerful of them, a module. So what's this one doing? This is it. So this is another one. Okay, yeah, this one was a good one too. So do y'all know how objects work? If y'all know how objects work, you can understand like how you call an object. So you call an object like, let's go here. Let's make an object var object equals hi. Up. Then I can console log hi dot or object dot hi, and then I should get. So what an object is it allows you to access something inside curly brackets by a key. So this is my variable object that has a key of hi, and then I can access the data inside of hi. So if I change this up, I get 2. And then you can nest them. So I can have another object of sup, and then hello, and then I can have so then I can access sup.hello, and then I should get 3. Oh, they're chains. You can you just they're nested. They're nested variables that you can access its data. I know I'm not doing a very good job explaining what objects are, but this is a good way. This is how modules function. This is a big thing. So if I had a function here, function log. I'm not sure if this will work. I don't usually normally use these with functions, but should. Didn't call it right. I have to call it with that because I'm initiating a function now. So this is essentially an object is essentially allowing me to work it like a variable. This is essentially a variable that has something assigned to it, or yeah, that has something inside of it, and it just happens to be a function that I initiate, and then I get the return value of console.log. Yep. You already understand modules now. So if we go back to this, that's essentially what this is doing. It's returning functions inside an object. So when we go through this, we have something and another. Those are just variables that do something, right? Where's another? Oh, another join explanation point. Okay. So these are just variables that are being used inside a function. These are the actual function calls, but they are here. So these are the function calls inside of our module. So when we run cool module and we set this equal to foo, what we just did is we returned an object with the functions attached to them. So when we return this object with functions attached to them, we can now use our, whatever this was assigned to, our foo now of the module. This is just object. This is an object being returned to foo. Now we do foo, which is the name of our object, dot the object name, which was just like hi. This is foo. This is do something. And then we get our console.log of cool. That's it. That's all modules are. Is that helping you out, Jose?
Yes, yes. It's more clear now.
It is? Okay, good. Yeah, those are the two big ones that I was confused with when I read through this, and talking through with some of the people, like again, I just keep repeating myself over and over again. This really helped. And this is just another way, a self-initiating function. So it was this IEFF thing up here. It just auto-runs the function, the module, and sets it to foo, and then it just gives you access to those objects and allows you to run them as functions to get what's inside the object. This is what jQuery essentially does. So this is how you keep it separate. I can't access any of this stuff until I run the function. This stuff is not in global scope, so I can never do anything with it. Yeah, if that's why JavaScript, okay, what he said was, I guess I was getting a little hung up on the idea that modules were something complex and different, but they're really just functions and objects. Yeah, JavaScript is really just objects and functions. Now people make they have some great ideas on how to use these things, which gives us this stuff, but that's essentially all they are. It's just utilized very effectively. What's this one doing? No, so it's just a function that accepts an ID. So this is a module that accepts an ID when we run when we call the module, and we return an object with the function identify on it with the console log ID, and we can do multiple module calls with different IDs to get different output. Yeah, that's easy. This one looks a little bit more rough. So we're calling an ID. We're setting a module to a variable foo. So that's our object. We have ID here. ID is down here and here. So we do so we have two IDs. It's a little bit different. Oh, no, it's not. Okay. So all we did on this one, first off, I'm going to ask, does this make sense with y'all looking at it after going through it in your head? Can y'all figure out what's going on just by looking at it now?
No, not really.
Okay. Well, you, Steven. Okay, cool. So we'll go over it with you, Jose. Let's see here. So this is probably the most confusing line of this. this part right here and this part. This is a little bit different on how they were doing it up in these other two examples. This is a self-running function, so whenever this var gets set and that actually executes, the module automatically gets run. And then down here, this is where the actual call for the module happens, and then this is where we actually pass in the ID. So the cool module ID is just this. This is the function call for cool module. So this is what's going to be going into this code. That's probably the most confusing part of that, but we can walk through this stuff in here too. So when this whole section runs, this part and this part, and then of course all the stuff in between, foo now has access to change and identify because public API was returned to foo. So public API is foo. So when we want to access something inside of here, we have to do an object call on foo. So foo dot one of the functions. So when we do foo dot identify, we run identify one, which is just a console log ID. So we get foo dot module or foo module. So when we run foo dot change will reach inside this function. So this is a lexically scoped function that we're running from outside, but it does something to the code inside. So what this does is it changes this right here. It runs this function identify to, and it does that by this call right here. So when we run the foo dot change, it runs this piece of code and it sets this function's return data, this to uppercase, sets it to identify. So now when we call identify, foo dot identify again, we get the capitalized stuff. That was the second most confusing part, was this and then this. That's the first time we've seen a module change itself from the inside by calling it from the outside. So this foo dot change essentially cause it to work another function. It essentially just set itself to another function. That's all it did. But we're still using the same call. So this got changed. And I'll visually represent it here. This should help explain it. Run it real quick, make sure it works. Module be good. So when foo.identify gets called, all we're doing is calling identify one, which is this, console.log ID. That's what we got. Foo.module or foo module, which was this right here. So when we do foo.change, all we're doing is we're going and we're gonna go find the change function. So this ran and we set public API .identify to identify to, which is a function. So when that got set, it changed this to, now, if I were to run this again, we should get 2 capitalized. That's what we're gonna get. Because I made this first set to identify 2 instead of identify 1. That's what change does. So hopefully that makes more sense to you guys. I know this one was a little bit confusing because it's doing something internally, but it's still the same practice of returning an object that gives you access to functions. But this one just so happened to change the object function, and it keeps using the same object call to run a different function. So what's this one? This one I didn't even try to go into. This one was confusing to me. And this was, it says for illustration purposes only. This is the one that went over my head too. because it all happens here. This is the stuff that I don't get. But that's for another day. He says it's even for illustration purposes only, so we don't have to get it. He just wants to show us. So do y'all have any more questions on closures, or did we clear some confusion up for you guys? Cool, cool. I think we're done with this book now. Go back. Yeah, that was the last piece of this book, of that chapter in scopes and closures. It goes into, you still have like the appendix A, dynamic scope, kinetics B, polyfill block scope, lexical this. I didn't really try to understand that too much. Not gonna lie. He said it's just for, I think he said it's for reference purposes. He wanted to add it in because he does talk about it a little bit, but it wasn't something that it was a dire need to know like the rest of the book or series. So that's something I'm gonna go back to later, but I'm gonna be honest, I didn't really try to make much sense of those. So I think that's about it. If y'all don't have any more questions, one more thing I wanted to touch on that we didn't do. Where's that? Where's that go? Slack. Okay. I forgot to touch on the YDKJS scopes and closures sheet. There were some questions on there that I didn't answer. Hopefully I can answer them. Move this here. Okay. Share my screen again. Example of passing undefined as a parameter is a bit confusing. Why would you want or need to set the value of undefined to be true? It's about halfway down the page in chapter 3. I don't remember that. I think he's talking about this. Or they're talking about this. I'm not sure on this. I'm trying to understand it too. I think this is just for testing purposes. I don't think it's what you. I don't think you want to do this at all. He says it right here: setting a landmine for other code. Avoid. So he's saying don't do this. I'm not sure. Y'all might have a different take on that. Yeah, he says don't do it. So yeah, there it is. Minor niche. Yeah, this is something, I don't know why you would do it. He says it up here, but I think most people wouldn't be running into that issue to where they would need to do that. This and object prototypes, chapter 2. This all makes sense. To example, just both object. This and object prototypes, chapter 2. Oh, this is on, we didn't cover this. This is on a different one. This is for next week. Yeah, these two are for next week. So it's literally just this one. This is on this and object prototypes. So I think that's it, guys. If y'all don't have any more questions, I think we're good for tonight. I want to thank y'all for joining. Without y'all, we couldn't do this. I'd just be sitting here by myself. So I appreciate y'all jumping on and taking your time out of your day to go through this stuff. Yeah, hopefully next time we can get some more people on here and we can have a lot more people trying to do this instead. Get some different takes on this stuff, maybe different ways to explain it. That's always helpful for me. I might hear it one way and the guy's saying the exact same thing as somebody else, but the other person might just say that one or two different ways of saying it, and then it'll click for me. Glad to hear it, man. Well, I appreciate it again. Thank y'all for jumping on. If y'all ever need any help with anything, I'm just Colin Perkins, so at Colin Perkins. So just send me something if y'all ever need any help, something to clarify. It helps me. I like explaining this stuff to people. It helps me kind of grasp it more. So it goes for anybody watching this. I appreciate it, guys. So I'm gonna stop the broadcast.